Okay, in this video we're going to talk about slope, and we have been studying about linear equations, and we've been plotting points that are solutions to linear equations and noticing that they seem to form the shape of a line. So in these next few lessons we're going to prove that those graphs are lines, and we're going to be able to describe them different ways, graph them, and really work with them a lot. So this lesson, we're going to talk about slope. And so slope is a number, and it describes how steep something is. And in the case that we're going to be working with, it's the lines on a graph. But slope is used to describe lots of things like roads, and in this case, in this picture here, the slant of a roof. And so when someone's building a house, there are certain, depending on the type of material that the roof's made out of, it will need to slant in a certain direction. And so what we look at is we look at how far over this roof goes, and for that given distance, how far up. So if it goes up a lot for a given distance, we'd say that's very steep. And if it would only go up a little, that wouldn't be quite so steep of a roof. Okay, so slope is a way to describe the steepness. So on a coordinate plane, we can have lines in coming in lots of different ways. We can have some that are slanting different directions, slanting the same direction, but one being steeper than another. So what we want to be able to do is use the grid units on the coordinate plane to show that for a certain amount over, a line goes up. So in the case of this orange line, we come over 1 unit and we go up, looks like about 2. And so that steepness will be described in terms of units on the coordinate grid. And we're going to find out that it's actually a ratio. Okay, so on the coordinate grid, there are really 4 basic things that a line can do with regards to slope. So let's look at those. So you can have a line that as you move from left to right, it slants up. Or you can have a line that as you move from left to right, slants down. The other 2 things you can do are you can have a perfectly horizontal line, or you could have a vertical line. So we're going to see in the next few minutes how these 4 basic things can be easily identified. The slope, certain characteristics of the slope can be easily identified this way. So let's look at our next slide here to see what is going on. Okay, so the pictures here kind of illustrate a convention that we're going to use when we talk about slope. So we always want to think of facing from left to right. So this penguin here is skiing, and he's skiing in this basic direction on all 4 of these coordinate grids. This one's a little different. But on the first 3, he's definitely facing in the positive X direction. All right, because if you think about it, if this is a hill, the only way you can know if it's going uphill depends on which direction you're facing. If I was traveling this way, then I would be going downhill. But since I'm facing this direction, and that's going to be our convention, then this penguin's going uphill. Whereas if this line drops from left to right, we're going to call that a downhill slope. And then down here, it doesn't rise or fall, so we're going to call this a, flat slope. Okay, so we can assign values to these, and so we're going to say that the slope here in this first grid is going to be a positive slope. All right, and so just by looking at it, we're going to learn to calculate a number for the steepness, but I know that any line that rises as I'm going from left to right, if that line's going up, that's going to be a positive slope. So you can guess that over here in this next section, if that line drops as you go from left to right, that's going to be a negative number for that slope. Okay, and kind of stands to reason that down here in the corner where it doesn't rise or fall, this is going to end up being a slope of 0. And we'll verify that as we come up with ways to calculate it. But those will be a 0 slope. This fourth one, is the one that we need to talk about. This is a vertical line. And if you look at it, it has, it's really, really steep to where this penguin is just going to be on the ground. But this slope is going to end up being undefined. Okay, so you'll see in the title of some of these lessons that we're going to only look at slopes of non-vertical lines. So we can look at horizontal right here, and we can look at the upward and downward sloping lines. But we're not going to, we won't be calculating the slope of a vertical line, so only non-vertical. Okay, so now let's look at the opening exercise in your classwork. And here we have two graphs, graph A and graph B, and I've darkened the lines a little bit so you can see them on the screen. And we're asked which graph looks steeper. And if you look carefully, now I've drawn the line in graph A so that it's a longer line. But if you look at graph B and you think about which hill would be harder to climb up, graph B rises faster. So graph B certainly looks like a steeper line. All right, so but we want to actually have a number that we can use to describe these lines. And so we're going to walk through just how you can start to think of this numerically. Okay, so part B of this exercise asks you to write directions that explain how to move from one point on the graph to another for both of these graphs. And so points are marked for you. And as I look here, I see a point marked here and here. And I'm asked to give directions to get from here to here. And my directions are going to be, for these exercises, and you're going to do a few of them, to move, how far do you move up or down, and how far do you move left or right to get from one point to the next. Okay, so if I'm here, I could go up 2 and over to the right 3. And that would be my directions for moving. I'd go up 2 and to the right 3. And then on graph B, I would need to go up 1, 2, 3, 4 and over 1, 2, 3. So up 4 and over 3 on graph B. Okay, and so then in part C, I'm asked to write these directions as ratios. So I'm going to write it as the amount that I move up or down compared to the amount that I have to move over. So in this case of this first graph A, let me get a different color here. I moved up 2, so the ratio would be 2 units up to 3 units over. And in the case of graph B, I went 4 units up and 3 units over. All right, and then if I compare those two ratios, I can see that the ratio for moving between 2 points on graph A is less than the ratio on graph B. Okay, so we are going to eventually get to calculating slope, but for now we want to just compare these ratios of moving from one point to another point. And so what I'd like you to do is pause the video, and you have pair 1, 2, 3, and 4. And you can work on doing this exact same method on those 4 pairs of graphs. Okay, so for pair 1, hopefully you saw that graph A is much steeper than graph B. And the directions to get from graph A to graph B would be, or not graph A to graph B, but from one point to the next on graph A would be to move, this for graph A, it would be 4 units up, and then for every 4 units I move up, I'm going to move over 5 units, 5 units right. And for graph B, I'll be going up 1 unit and then way over 12, okay? So not very much rise. The graph doesn't rise very much for a long way across. So that's not so steep, right? So that's how we're going to write this ratio. So this would be, this ratio over here would be 4 units up for every 5 units, and the ratio for graph B would be 1 to 12. So if you look at those two fractions, you can see that 4/5 is larger than 1/12. So for pair 2, this one we went, we needed to go 7 units up and then 1 unit over for this graph. So I went from here up to over to here. And then on this second graph, I'm going to be going 3 units up and 6 units over. So 3 units up and 6 units to the right. And if I look at those two ratios, this ratio over here for graph A is 7, and this is 3/6, which is 1/2. So clearly 7 is the greater ratio there. And we notice it's the steeper graph. So steeper, not so steep. Okay, so for pair 3, again, checking your work, right, because you've already done this. I'm going to be going from this point to that point, and so I'm going to have to go up 1 and over 5. And then for graph B, I'll be going up 4 and over 1. And so what that looks like as a ratio is up 1 and 5 to the right, and on graph B here, up 4 and just 1 to the right. So the steeper graph again has the greater ratio. 4 over 1 is greater than 1 over 5, or 1 to 5. Okay, so as I look at pair 4, I look at these two graphs and they look roughly the same, so it's very hard to tell if one might be steeper than the other. And when I go to do the directions for getting from one point to the next, for graph A, looks like I'm going up 1, 2, 3, 4, and over 1, 2, 3, 4. So that ratio is going to look like up 4 and 4 to the right. And then as I look at graph B, to get from this point to this point, I'm going to have to go up 1, 2, 3, and over 1, 2, 3. So the ratio would be 3 up and 3 to the right. And I'm going to notice that those two graphs have equal ratios, because 4 to 4 is the same as 1 and 3 to 3 is the same as 1. And so these graphs have equal ratios, and they look like they have the same steepness as well. Okay, now we're going to take the next couple minutes and just come up with a definition of slope. And so we've already said we can tell if a slope is going to be positive or negative. Remember, we want to give a number that's going to describe the steepness of any line on the coordinate plane. So we know that this particular line that you're seeing in front of you is going to have a positive slope because it leans, as I move from left to right, it's rising, okay? So it rises, so it's an uphill slope. We're going to give that a positive number. But we want to be able to give it not just positive and negative, but an actual value. And so we're going to work through kind of constructing something here. So we've got this line L. It goes through the origin at point P. And what I want to do now is I want to mark off a distance along the x-axis of exactly 1. Because what we're going to say is that, and we're going to call that point, we're going to give that point a label, and we're going to call it Q. Because what we're going to do, and then this, we know this distance here is equal to 1. The length of PQ is equal to 1. And what we want to say is we want to know for moving over 1 unit, how far up does the line rise? Okay, and so if we construct a line going straight up from Q through the line, I'll make sure that's straight up and down, it's going to intersect the line at another point, and we're going to call that point R. Okay, so now we have our line labeled. And if I kind of take this over to the y-axis here, the y-coordinate of that point R is going to be M. We're going to use the letter M for slope. So whenever you see slope, it's going to, M equals something. And so we're going to say that this length right here, which is the length of QR, which equals M, is the slope. All right, and we can see if we translate this. Okay, so to do a translation, I would need, a overhead or whatever. So what I'm going to do is try to do this for you here. So I'm going to trace out kind of this triangle here that sort of describes the slope of this line. And let's see if I can get this to move over. So I want to translate it so that point Q is at the origin. So it kind of goes over there. And so what I'm seeing here, so this would be, P prime, Q prime, R prime. And what I can do is I can now read the slope right on the y-axis. So the slope of this line is the value M. And we can see it's positive, right? Because this line is going up. When I move over, I'm going to be in the positive part of the y-axis. So this line has a positive M slope. Now here's an example with numbers, with the axes actually numbered. So you can see here that this has been moved, might have been in another location right here, but we've moved it over so we can read the slope right on the y-axis. Notice that the distance along the x-axis, PQ, is 1. And so moving over 1 unit, this line rises 2. So in this case, the slope of this line, I'll get my writing instrument here, M equals 2. Okay, now let's use the same technique, but this time we have a line here that you could identify as a negative slope line because as I move from left to right, this line is dropping. So this is a downhill slope. It's going to have a negative value. So let's do the same thing. So we've moved over to point Q, and now I'm going to drop a line straight down from Q to the line, and I can mark my point R on the line here. So it's going to be point R. And now what I want to do is move this over to the y-axis so that we can read it. So I'm going to do that same trick where I trace this out, and then I'm going to just move that whole triangle right over. Right there. I wish I could leave the purple behind, but it goes with me. So, so now I know that this y-coordinate down here, get my pointer tool out, so I can read the y-coordinate here, and this will be M. Let me erase this here, get that out of the way. So the y-coordinate here will be M, and that is my slope. And notice that in this case, this distance M is falling on the negative part of the y-axis, so that slope is going to be a negative number. Whatever M is, it's negative, okay? So here's a numeric example that shows that. Let's look at this next screen here. So imagine this line was just moved over, and sorry. And so we have our triangle here. And so the slope of this line, so when I move over 1 in the x direction, this line is dropping 3. So this, in this case, this slope M is equal to -3. So it's the y-coordinate of the drop in the line when I move over one unit. Okay, now let's look at an example of a line that doesn't go through the origin. So what would be, now the line that you're looking at now, line L, is that going to have a positive slope or a negative slope? Okay, so let's find out. So I'm going to pick a point P on this line. So here's the point P, and I'm going to come over 1 unit and find a point Q. All right, so I need to draw a horizontal line, and I'm going to draw it through P. Whoops, that's not good. So there's a horizontal line through P, and I'm going to come over 1 unit to Q. So here's, we'll call that 1 unit, and there's my point Q. And so remember, the distance PQ is 1. And then I'll put a horizontal line, not horizontal, vertical, through Q and up to my line. And so let's see if I can do that here. I want it to actually go through Q. All right, that's pretty good. So there's my, there's Q, and so where it crosses my line, that'll be the R. So we still have this triangle here, PQR, where this distance from P to Q is 1. Right here, this distance is 1. And this distance here is going to be my slope, and that is, you know, this is distance QR, but I can't read it directly yet. But if I translate this whole triangle, once again, down to the origin, so let me trace it out. Let's use a different color here. We'll use green. So let's trace out this triangle, and we can translate this whole thing down to the origin here so that we can read that value of QR. Okay, so I've taken that triangle, so this number here on on the y-axis is going to be my slope. So whatever the y-coordinate is there, that is the slope of the line. So see how we've just made it into that same thing. So what we're looking at here is for 1 unit change in x, how far up does the line go? That's the big idea here. For any 1 unit of change in x, what does the line do? Is it rising? So in this case, hopefully you realize that this line here had a positive slope because it was moving up as x moved from left to right. And here we see that it is on the positive side of the y-axis, so it is a positive slope. So the technique that we're using is going along with what we knew before. Okay, so let's look at an example of that. Okay, so in this example, we have a point P and a point R, and we can see our point Q at the origin. So notice that from P to Q is 1 unit. It's marked off in half units here. Every tick mark is a half, but PQ is 1 unit, and we notice that the line is rising 1.5 units. So for this, in this case, we could say that the slope is 1.5. The slope is 1.5 for this line. One thing we're going to learn about slope too is that it's often written, it's not usually written as a decimal number. So if it's not a whole number, it's usually written as a fraction. So how can we write 1.5 as a fraction? Well, it's 1.5 or 3 halves. So we could also write it as 3 to 2. All right. So we'll leave it at that. All right, you can work through exercises 1 through 6 independently, coming back to check the video, and I'll show you the correct responses. So go ahead and pause now and work on exercises 1 through 6, or work on them one at a time, checking as you go. Okay, so for this first one, we have this slope triangle right here. And as when we translate that over to the y-axis, like we talked about, we can read the slope off as exactly 4. Now you don't have to move it over because you could have seen the height here. Whoops, I wanted to point to it. This height here, I could just count it off on the graph as 4. But if I move it over, I can read the slope equals 4 directly. So in this case, m is equal to 4. And it's a positive slope because it's going up as we move from left to right. Okay, so in exercise 2, I can see that I move over 1 unit to Q and up 3. And if I want to translate that triangle, I can do it this way by tracing it out and then just moving it down so that Q is at the origin. And I can read off the slope directly then, and the slope would be m equals 3, or a slope of 3. So what that's saying is that when I go over 1 unit in the x direction, I go up 3 in the y direction. So that's a slope of 3. And then exercise 3 asks me which of the lines in exercises 1 or 2 is steeper. So you'd want to go back and look at those. And you will notice that the line in exercise 1 is steeper and its slope is 4. So the relationship between steepness and slope is that the steeper the line, the greater the slope. Okay, I hope you noticed in exercise 4, we have a negative slope. And so as I come over here to Q, the line is dropping. And so when I take that slope triangle and translate it over to that, whoops, I had that drawn right there, and move it over so that the Q is corresponding there. I can see that the slope of this line, M, is equal to -1. And I'm reading that right off the graph, right off the y-axis here. Okay, so for a change in x of 1, the line is dropping 1, so that's the slope of -1. All right, and for exercise 5, I can come up here to my slope triangle. I can see this is also going to be a negative slope. And what I want to do is trace out this, whoops, sorry. There we go. Trace out that slope triangle and go ahead and move it down so that I can read it right on the y-axis. And so it moves down there, so I can see that that slope is -4, because when I move over 1, this line is dropping 1, 2, 3, 4 units. And the slope triangle over here just shows it really nicely, a slope of -4. So M equals -4. Okay, exercise 6 again says, what is the slope of this non-vertical line? And you might have noticed this non-vertical line is actually a horizontal line, perfectly horizontal. And so when we have our point P and we move over exactly 1 unit to get to Q, we don't end up quite with a triangle, because when we go to draw our line Q, we don't go up or down to the line. We end up staying right on it. And so really what I'm doing is, I'm kind of thinking of moving, as I move this point Q right over here to the origin, let me get it just right, right over there, I can read the slope, and the slope is 0 because it's right here. Okay, and so we're going to say that the slope is 0 for a horizontal line, because when I move over 1 unit in the x direction, the line doesn't go up or down. I'm already on the line. Not sure why they put this R over here, so we'll just ignore that. But just know that the slope is 0 because this line is neither rising nor falling. So the slope is 0, right in the middle between positive slopes and negative slopes. One thing to notice about negative slopes, if you look back at exercise 4 and 5, is that in 5 we had a really steep slope and we got a slope of -4, and let's go back to that, we got a slope of -4 on that one and a slope of -1. So when we're looking at negative slopes, the steeper lines like that one have a larger absolute value. So it's a bigger absolute value. It's actually a smaller number, because remember that -4 would actually be less than -1, but the absolute value of -4 would be a greater slope than the absolute value of -1. And so with negative slopes, we're really looking at absolute value. Okay, so we have one more example to look at, and you're going to see some problems like this in your problem set. So this is from lesson 11, I believe, and it's a lawn mowing. So you plotted these points. So you found out that Pauline could mow 35 square feet in 2.5 minutes. And so we came up with this equation here and saw that in 0 minutes, she could mow 0 square feet. In 1 minute, 14 to 28, and so on. by doing the math on this 35 divided by 2.5. All right, and so that led to a graph that looks something like this. So the graph shows, and we've connected these points with a line here. So down here we've got time in minutes. So we've got 1 minute, 2, 3, and up to 7. And then here is the square feet of lawn that she mowed, okay? So in 1 minute, she could mow 14 feet. Well, what is the slope of this graph? Well, the slope, let's get a pencil here. So if we look at this triangle, if we come over one unit, we notice that we go up 14. So the slope here is 14. And sometimes slope has units. In this case, it does. And it's square feet per minute. Okay? So notice that the slope here is her unit rate. Remember, unit rate, the amount she could do in one of those units, whatever it is, in this case, minutes. So in 1 minute, she can do 14 feet. So slope is the unit rate. So you'll look at some more examples of that in the problem set for lesson 15, which you are ready for now. You can do the exit ticket and the problem set. And so let's just really quick summarize. So we saw that that lines that move up as we go from left to right have a positive slope. Lines that go down as we move from left to right have a negative slope. And we saw how we could read using 1 unit of change on the x-axis. Our slope is the amount of rise or fall for the line. So this case, the slope here would be 2 in this example. Okay, so you've learned what slope is, and you are ready to tackle these exercises.